Coming up on this episode of the IoT Inc. Business Show.
So I think that's my surprise. So many people tend to think of security as all or nothing, but it's anything but.
Yeah, and I just added that by saying that in a lot of the projects that our company sees, it's definitely security through obscurity, and the expensiveness point actually is definitely pervasive. It's almost from a compute resources perspective. Like if somebody had the choice between adding a certificate or a decryption algorithm versus getting just a little bit more analysis off that device, they'll pick the analysis off the device over security.
After going through each of the major consortia, we're heading back to tech, but not as deep a dive as usual. Having left the edge behind, we're now moving on to the network fabric that holds everything together. In this episode of the IoT Business Show, we talk about some of the most important issues surrounding IoT platforms today.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com.
My name is Bruce Sinclair. I'll be moderating this panel discussion of the top 5 issues in IoT platforms today. First, I'd like to have our panelists just introduce themselves.
Sure. My name is Justin Buchanan. I'm head of Cisco's Enterprise IoT Group.
My name is Bryan Kester. I'm the CEO of C-Control, which is a no-coding IoT platform.
Hi, Steve Jennis. I'm the Senior Vice President of Corporate Development at Prism Tech.
My name is Brandon Harris, and I work at Electrocamp, a cloud services and hardware platform provider for the IoT.
Well, the 5 issues, or at least the 5 top issues that we're going to discuss today are security, sensor compatibility, analytics compatibility, APIs, and standards. Maybe to kick us off, Justin, you can give us an overview on the security issues with IoT platforms.
Sure, yeah. I mean, I think a lot of the folks that we're talking to today, one of the things that they're very excited about is all these devices coming onto the network. But what scares them the most is that now these devices are on the network. And as we look kind of across different industries and verticals, there's certainly different things you can do from a security perspective to harden the devices, as well as segment users based upon where they are in the enterprise themselves. We've heard of some very high-profile cases where you have PCI card readers talking to other devices, and there's obviously different ways to do that, but something that's top on everyone's list.
So is this model a typical IT model? Are we just securing each layer individually as we do, let's say, in a closet-based deployment, or is this a little bit different?
Yeah, I think there are some differences. I think that in some ways it's actually simpler than what we're doing today. In standard IoT, in standard enterprises, users move around, and IoT devices tend to remain static, so they're not going to move around. So we'll have better ability to segment them based upon device type. In some examples, the OT per se, you will firewall those, but there are certainly challenges when you bring end users and IoT devices onto the same network.
What has been the panel's experience? Any surprises maybe that you've come across from a security? I mean, has there been anything that kind of caught you off guard with security, kind of in this world versus in the traditional world?
Yeah, I think one thing that surprises me is how people tend to talk about security in a sort of binary sense. You have all or nothing, and we know from long experience that security is only as good as what you'll pay for, right? Even military systems you very often get asked to quote a certain level of security, and then they come back and say, well, that's way too expensive. What can you give us for X dollars? So I know it's not a very clear-cut answer to the problem, but people need to understand that security is scalable. It's not all or nothing, and you have to learn to live with whatever security you're prepared to accept. I mean, just like online banking, right? I mean, we were very nervous in the early days, but we've become more comfortable with it. But it's just as hackable today as it was 10 years ago. So I think that's my surprise. So many people tend to think of security as all or nothing, but it's anything but.
Yeah, and I just added that by saying that in a lot of the projects that our company sees, it's definitely security through obscurity, and the expensiveness point actually is definitely pervasive. It's almost from a compute resources perspective. Like if somebody had the choice between adding a certificate or a decryption algorithm versus getting just a little bit more analysis off that device, they'll pick the analysis off the device over security.
Because of the trade-off in
the early stages. And then, of course, people get to scale sometimes, in some cases before they know it, and realize, I kind of forgot about security. And then it's an overlay. And like a lot of things, all those kinds of problems can be solved. Good problems to have if you're scaling at that sort of speed. But we don't see a lot of it like in our business, especially in the early days.
This is Brandon. I think one of the biggest traditional changes from a traditional security model is, and one of the things we found is people often have physical access to these devices. And whereas a laptop or other network equipment is secured with passwords, and there's easy ways to authenticate a user to that device, it can be very challenging to authenticate when you are just a sensor node or you have a few buttons or actuators and things like that. And so establishing that trust and who has access to those devices is very complicated. And one of the things we found, and something that we worked very hard on at Electric Imp, was actually baking security into the hardware level, where literally looking at how we communicate externally to the chip, what portions are allowed to leave the system unencrypted, and things like that, and preventing readback to prevent security keys from being able to read back. And we've found and done a lot of studies, very sophisticated hardware hacking going against these kinds of devices, where they're able to extract a key that has been used for more than one device, and effectively, while they have physical access to one device, they've owned the network of all of those devices, and that's very different from a traditional environment.
And I guess there seems to be what is your view in terms of let's just say the advice that what's the top level I guess issue with security when someone's looking at an IoT platform, what should they be thinking about, I guess, at this point?
Well, I think the first thing is to have a plan, right? I mean, a lot of folks, I think they just bring these devices on, and there's no clear ownership of who owns what. Within an organization, is it the IT department that owns the security? Is it the security department within IT that owns it? Or is it the vendor, the IoT vendor that owns the security?
So come up with an ownership and a plan.
Yeah.
Well, let's move on to sensor compatibility. We've been hearing a lot about the different sensors that are available, but also there's a siloed. There's an issue of I guess availability within your silo. But if you're looking at an IoT platform, what should you be thinking about from a sensor compatibility point of view? Steve, why don't you start us off there?
Yeah, it's Steve Jennis again. I think the ultimate destination that we're heading in is very much in a data-centric world. The additional value that the IoT can deliver is based on, as I've said many times, the free flow and accessibility of data. So it's a journey, because you start the journey with what you have, right? You very often have legacy systems that are limited in how and what they can communicate. As you evolve to a much more data-centric view of the world, you start to think of data sources and data sinks, and a sensor is a data source. as really a slave on the system, and it needs to do what you want it to do. It needs to provide you the data that you need at a certain latency and a certain frequency to suit the data-centric nature of what the system's seeking to achieve. So it's not a silver bullet. I think in the early days it will all be about custom integration of critical existing sensors and actuators and any other edge device. But as we move into the future, those devices will become more sophisticated. The onboard compute power will grow immensely. Memory constraints will disappear. Putting a software agent that takes up a few hundred kilobytes will be a non-issue, even in the smallest sensors. And so the world will evolve towards a data-centric philosophy that the sensors have to step up and offer more onboard resources. And ultimately, if they can't, you still have the idea of a sensor subnetwork, which can communicate through a gateway where you have some edge analytics at the gateway to aggregate the data and do the first level of analysis, and then go onto the backbone of the system with the results of that analysis for big data or whatever other analytics. But I think it's wrong to think of the sensor as driving the system. The system has to drive the sensor, and I think that's where we're headed in compatibility.
Does everyone agree with that? Is it because you could look at it the other way too, couldn't you? I mean, if you start with the business problem or the problem you're trying to achieve, you're measuring something that you're valuing, and so isn't you're first defining what you're trying to value, and then you're trying to sense that. So isn't the sensor kind of the tail wagging the dog on that?
That's a very valid question, Bruce. And I think the way I'd say is that people are asking, how does the IoT or the industrial internet or the digital enterprise differ from what we've traditionally done with M2M or real-time distributed systems? And the answer is there, to me. You can do a lot in the bottom-up context, tactical. As Bryan said earlier, many customers are still experimenting to find out what pays back and what doesn't pay back. But ultimately, if you look at the digital enterprise and the concept of the digital enterprise, the data flows seamlessly and is available where it needs to be on demand. And that can be in the cloud, it can be at the edge, it can be at the gateway. It is a bit of an idealistic philosophy, but it's hard, to me, it's hard to define what extra the IoT brings over traditional automation approaches if you don't look at it from that perspective. So it's system-wide, seamless rather than siloed, constrained. So it's strategic rather than tactical. And if you think about what the internet allowed in terms of social media, it was all about that unconstrained movement of data between thousands of nodes, whether they were Twitter nodes or Facebook nodes, and that's what opened up the world.
But are we there now, though? I mean, are we at a point where we can have this data flowing with the sensors?
I wouldn't dare to answer that question. I think everyone has a different answer to that question. I mean, clearly, companies like GE evangelize, the concept of analytics anywhere in the hierarchy of the organization. Whether it's a brilliant machine or whether it's a big data aggregation and analysis. Other companies may be a million miles away from that concept today. Some people think connected car is old news. Some people think it's breakthrough. What was it? Elon Musk said that the 2015 model will be connected vehicle or something like that. Within 5 years, I think he was saying they'd have a fully autonomous vehicle on the road, and that's a bit scary for most of us.
For our part, our notion of sensor compatibility is the idea that if you're in a highly distributed network in a mission critical application, you want the sensors to talk to each other because your network may go down, and you still need your operation to keep running out there. So, there are a lot of use cases at the high end that have been in place for years, particularly in plants. I mean, plants run for the most part as like isolated islands of information. with lots of sensors in them. Same thing with the vehicle. A vehicle has hundreds and hundreds of federated sensors, but the standard there is something called a CAN bus. It's an in-vehicle network, so they all know how to talk to each other. As a practical matter at the enterprise level and some of the industrial stuff that we do, people are just starting those kind of mixed sensor deployments where they're closing the loop and doing really, really interesting things with multiple sensor types in a value chain or in a business chain. But we tend to think of it sometimes as like as a value add problem, like how do I close that loop? And then if I want to close that loop in a business context, it's a resiliency thing, like what happens if I'm occasionally connected or the network's gone.
Brandon?
This is Brandon from Electrocamp. I disagree a little bit with the idea that we're moving to a world where things still need to communicate locally. When I moved into my apartment, the first thing I set up was my internet, and then I set up my bed because I wouldn't sleep at an apartment that didn't have internet. That's where we are, is that we're so connected to our devices, and I think if you start viewing internet connections as part of critical infrastructure, if a plant loses power, they shut down as well. What do? They have backup generators, right? They've taken provisions to accommodate these losses of network and loss of connectivity, and the same thing can be done for connected devices. I think there is a tremendous challenge to make something that functions the same or seamlessly, whether there's an internet connection or not. And I think it's for certain applications, it's obviously a requirement. Like there are places where you cannot have reliable networking in this day and age. But I think that there's a lot of applications where we need to sort of release ourselves from like, the network might not be there, because there's a lot of great things we can do if we say we only function if we have the internet, right? We can start tying in a lot of other services and make ourselves dependent on tremendous cloud infrastructure. We have all these resources available to us today, and to say, we won't use those because we might not be able to talk to them seems like a really poor design choice rather than solving the actual problem, which is your internet's going out.
Well, just a slightly different view on that is that concepts like automatic discovery, agile reconfiguration, agile reorchestration of the network, they have to be there to cope with unexpected scenarios. Now, I agree you can have backup internet, you can have backup generators, you can have all sorts of fault tolerance and backup systems. But another aspect of agility is new connections on the system. Do you have to reboot the whole system because you're adding a new node? Well, clearly you don't want to do that. In any mission critical environment, you have to be able to add and automatically discover new nodes on the system and seamlessly integrate them. So at the platform level as well, at the middleware layer, that's why you need to choose your protocol very carefully, because your protocol needs to support that automatic discovery and agile reorchestration. Another thing is if despite your best efforts you do lose a node on the system has to be fault tolerant. And when that node comes back up, the data that is overdue has to be handled in a very, very careful manner, because it has to arrive in the order it would have arrived and be logged, and from an historian point of view, in a sequential sense, So, you can't just have the data randomly show up again. You have to have the ability to, even if it's offline, to store that data and then to release it in a consistent and planned manner. So there's lots of things you can do at the data-centric level to offset certain vulnerabilities at the device level as well. But I do take your point that you shouldn't plan for failure.
Yeah, and I think people definitely, the scenario that you're talking about, it's kind of like first world, it's really easy for us to get internet connections anywhere. But if I go remote, if I go second or third world, where, like, for example, if I want to deploy like solar-powered cooking things out in the middle of Mongolia, that's a real, it's actually an interesting market opportunity for folks like in that region. Similarly, in emerging economies where you have infrastructure build out, where they're designing sensors in, like India and other folks, where it's unreliable, or the government, like for example, we had a customer in Costa Rica. It takes them 9 months to get an internet connection. So There's I think again on the kind of the first world, like especially consumer products and our data existence level, like yeah. But when I look at sensor compatibility, my thought was more that I'd love from a cloud perspective to be able to, if one node goes down and it's a sensor or a relay from vendor A, I'd love for it to be able to shoulder tap vendor B's sensor and say, can I piggyback off your connection, get it out of here? Which is a little bit of the version of like what, say, for example, BMW does with your Bluetooth connection. They send out some of the car's performance data, up over the BMW app that you're using on your iPhone. And so with their telematics connection goes down, then and they need some sort of service alert or SOS thing, it piggybacks out. So I mean, from sitting back in a cloud perspective, I tend to view it, kind of that way a little bit. But absolutely, yeah, point's very valid.
And so I might take a little bit of a different angle to this as well. And when I look at sensor compatibility, I mean, we talked about one of the 90% of the cost is in end devices, right? And getting the network going. I mean, wouldn't it be great if we had a single sensor that then could talk to other devices within the network, right? So I have maybe an occupancy sensor that can talk to my lighting system and my HVAC, right? So sensor compatibility is not just, it's not vertically integrated. And to your point, it's that data should be shared across the enterprise.
Yeah. Let's jump over to the other end of the spectrum of the IoT Platform Analytics. Bryan, can you just give us an overview of I mean, are analytics generally included in the platform, or do you have other options, or what are the compatibility issues with analytics?
Yeah, I think the first thing that is always kind of mind-boggling to some folks on our team is that you have to think about the fact that if you look at the software market in general, analytics is a multi-billion-dollar sector composed of lots of companies. So when you say analytics, and I don't mean you, Bruce, I mean just when people talk about analytics, it's about, well, what do you mean? Do you mean statistics? Do you mean I want to take 10 data feeds and do some cross-dimensional analysis that I might require a supercomputer for and hit run and come back the next day for the result? And so, so much of IoT, particularly in these earlier days, is like use case driven. It just varies. So for a lot of folks, I mean, and like certainly a lot of our customers, like analytics is real time operational analysis of problems that are happening out there. So at a simple level, is something failing? Does it have a trouble code? Is it too hot? Is it too cold? Et cetera. And then you move up to another level where you're starting to generate meta information around that. Well, the number of times it was too cold in Albuquerque in winter was this, and I had 12 equipment failures or whatever that use case might be. And then there's another level above that, which is kind of more that big data batch processing where we start talking about Hadoop clusters and things. So I think, when you talk analytics, you have to define, what layer you're talking here. And again, that just it rolls back to your use case, and also the scale at which you're deployed. So it's kind of like our definition of it. So we tell people all the time, like there's always fuzzy lines where you can say we can do that analysis or we can't do that analysis, and it's use case driven. That's and a lot of times it's data driven too. Operationally analyzing a terabyte of data is not something that's very practical or even easy to do. Or you can do it, but it's expensive.
Right. And that's another trade-off then?
Right, exactly, expense. And that's the other thing. So, I mean, everything it's baby steps towards coming to whatever you think your conclusion is. So start small with statistics and then work your way up to what machine maintenance people and product managers consider prognostics, or how do I predict when something's going to happen and forecast.
Do you have something else?
Just one quick comment. You can look at packaged applications, whether they're an analytics engine or some domain-specific application, in the same way as you can sensor diversity. Really, it's all a case of being able to plug these things together, and so you come back to APIs and you come back to ease of use methods of integrating heterogeneous, diverse environments into a platform scenario. So, it's not valid to think about a platform. I think it's valid to think about the platform as the backbone that integrates a lot of diversity, both at the device level and at the application level. And so you've got to, again, come back to choosing a protocol or an API approach that suits the diversity of your environment. Now, in the consumer world, it may well be very different. It might be all Apple, it might be all Google, it might be all Nest, and it's just plug and play. But in any enterprise environment, it's an integration challenge.
Yeah, what's the opposite of plug and play?
Yeah. Well, I think we just on that particular point, the systems integrated channel is something we don't often talk about, but it's a fabulous opportunity for the systems integrated channel, the IoT. And I think in a lot of vertical markets, the systems integrated channel is actually going to be the bottleneck. And many of us are old enough to remember the early days of SAP, where everybody was an SAP agent, right? So it may well be like that in a few years from now. Everyone will be a Cisco agent or a Microsoft agent, or the guy who's pulling everything together under that umbrella.
So I'm going to take a slightly different approach to this. I think one of the things I find so fascinating about analytics is many of us approach the Internet of Things from the internet side. We're used to servers and networking and things like that. My background is actually much more in the things space, so actually building physical products. And analytics is something that's completely new to thing manufacturers. Traditionally, the life cycle for a device was you build it, you send it to a retail store, somebody buys it, and maybe you get a warranty card or a warranty complaint for that device, and you probably get some online reviews, and that is the extent of your customer interaction. One of the things that's so empowering about getting these devices connected is actually for manufacturers to have real-time results of what their customers are doing, how they're using it. And it's incredibly valuable in the consumer space to understand customer behavior, and in the enterprise and industrial space because that can help drive ROI. So it's a really fascinating new thing that these thing manufacturers are doing, and most of them are really scared of it. It's a really challenging problem to approach when you're used to building dumb devices. So I think that, and it requires substantial changes in their business models. They now are generating data that is valuable, and many of them view the analytics side as a liability, that it's an added cost instead of finding the value in it to be able to sell more of their product, to be able to sell their product cheaper, to refine it. And so it really takes an internet approach to getting the Internet of Things, and really being able to adapt your business model to the fact that analytics is now something that is real and that you can do on devices and aggregate across lots of customers.
Yeah, and actually, just to touch on that great point, there are people that are starting to do this, but it's not lost on anybody, particularly here in Silicon Valley, that we're obviously generating all this data, and if you can anonymize it somehow, there's a variety of useful purposes for it, from just the betterment of everyone's good, whether it's food production forecasting or something on that level, to simple, like in our industrial world, just simple benchmarking, right? Like being able to trade a lot of customers' data about how their equipment and machines are performing, so that every single vendor has a benchmark from which to operate. Just like, for example, like in the airline industry, how they all know how long it takes generally to turn around a plane, until Southwest changed that paradigm at some point, but they used to all share that data. So there's a lot of innovation there where, and this might be bleeding into the value of the analytics a little bit, but we're starting to see the early, that early world starting to form around, in some cases, co-op editors or competitors actually sharing data for the betterment of their industry and trying to sell more products and services.
Yeah. Well, with that note, I think we'll end this panel, as we have a separate panel for both APIs and for standards. So thanks a lot.
Thank you.
Okay, that was an informative panel. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support this show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is the ever-evolving IoT platform with Bryan Kester. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be a balanced one.
You have been listening to the IoT Inc. Business Show.